What if our current understanding of the universe is actually wrong? What if the Big Bang wasn't the beginning of everything, but just another phase in an infinite cycle? And what if our entire universe, including galaxies, stars, planets, and life itself, exists inside a black hole that was born from a much larger cosmos? It might sound like science fiction, but an increasing number of scientists are looking into the intriguing possibility that we're actually living in a black hole, and that black holes themselves could be the building blocks of new universes. This radical theory could change how we see the cosmos as a whole. It challenges almost everything we know about space, time, and how our universe began. The story starts with what we think we know. 13.8 billion years ago, our universe was born with the Big Bang. This violent event led to the rapid expansion of space and the formation of matter. Galaxies formed, stars ignited, and eventually, in a small corner of the universe, life emerged on a tiny blue planet called Earth. From there, we started to understand the cosmos better, exploring things like where life came from, our place in the universe, and what existence is really all about. The Big Bang has been the go-to theory for explaining how the universe began, but as we delve deeper into the nature of black holes and cosmic evolution, a new and intriguing possibility has emerged. What if the Big Bang wasn't the beginning? What if it was just a result of a bigger cosmic process? Some scientists think the answer to this question might be found in black holes. This unusual theory suggests that black holes may be more than just huge cosmic objects. They could also be the origin of new universes. This theory suggests that every black hole has the potential to spawn a baby universe within it, and that the Big Bang could be the result of such a cosmic birth. If this is true, our universe could be just one in an infinite series of universes, each formed inside the black holes of a parent universe, continuing an eternal cycle of creation and destruction. This idea doesn't just change how we think about black holes. It completely rewrites our understanding of the universe and how it works. To understand why this theory is so compelling, we need to take a closer look at what black holes are really about. Black holes are areas of space where gravity is so strong that nothing, not even light, can escape. They form when massive stars collapse under their own gravity, compressing their mass into an extremely dense point called a singularity. The event horizon is the boundary surrounding the singularity. From an outside observer's perspective, nothing can return beyond this point. Anything that crosses this boundary is lost forever, seemingly pulled into the black hole's abyss. But what's going on inside the event horizon? That's where it gets interesting. The space-time fabric is severely warped inside a black hole. As a matter of fact, the laws of physics we're familiar with start to break down. For years, physicists have been wondering if something pretty amazing might be going on inside black holes. Some have even suggested that a whole new kind of space-time could exist inside. Put simply, what we perceive as the interior of a black hole could in fact be an entirely new universe, distinct from our own. One of the scientists looking into this is Nikodem Popovsky from the University of New Haven. Popovsky has suggested that black holes could act as cosmic wombs, giving birth to new universes. His theory suggests that our universe might have come into being inside a black hole in a larger universe. The idea is that when a black hole forms, the immense gravitational forces compress matter into an extremely dense state, similar to what scientists believe existed just before the Big Bang. This could create a singularity that, instead of collapsing into nothing, explodes outward to form a new universe. From the perspective of someone inside the new universe, it would look like the Big Bang. If this theory is right, it would show that the Big Bang wasn't a one-off event in cosmic history, but part of an ongoing process. It's possible that universes are continuously created inside black holes. Each universe might exist inside a black hole of a larger universe, and so on, possibly stretching back infinitely. This idea fits within the broader concept of the multiverse, which is the idea that our universe is just one of many, or perhaps even an infinite number of universes, each with its own laws of physics and cosmic history. But how does this theory account for the observable universe around us? One of the main ideas is that the observable size of our universe is the same as what we would expect if the entire universe were inside a black hole. To get a handle on this, we need to look at something called the Schwarzschild radius. The Schwarzschild radius is basically the size of the event horizon of a black hole. It's the distance from the singularity at which light can no longer escape. If a black hole had the same mass as the universe, its Schwarzschild radius would be about the same size as the observable universe, which is around 46 billion light-years. This is a pretty amazing coincidence. It makes us wonder if what we think is the universe is actually the inside of a massive black hole. But this is just the start of it. One of the most exciting discoveries of the 20th century was the cosmic microwave background radiation, a faint glow of low-energy radiation that fills the universe. This radiation is a remnant from the early universe, giving us a picture of what the cosmos looked like just 380,000 years after the Big Bang. What's really interesting about the CMB is that it's completely uniform. The temperature of this radiation is almost identical in every direction we look. This uniformity suggests that the universe was once very hot and dense, which supports the idea of a Big Bang. But some scientists think there might be another way of looking at it. They say that the conditions inside a black hole would also produce a uniform temperature and density, similar to what we observe in the cosmic microwave background. This lends further support to the idea that our universe could have originated inside a black hole. The idea that black holes might be involved in the creation of universes isn't just a theory. One of the greatest theoretical physicists of all time, Stephen Hawking, suggested that black holes could be the source of new universes. Hawking also suggested that when a black hole forms, it could create a new universe inside, separate from our own, by the event horizon. From the perspective of someone inside the black hole, the new universe would seem infinite. From the outside, though, the black hole would simply appear to grow larger as more mass falls into it. This suggests that every time a black hole forms in our universe, it could be giving birth to a new universe, creating an endless chain of universes inside universes. The implications of this theory are pretty significant. If it's true, it would mean that our universe is part of a huge multiverse, with each universe connected to the others through black holes. This also means that black holes are not just destructive forces, but also creative engines that give rise to new universes, each with its own unique properties and laws of physics. But is there any proof to back up this theory? That's where it gets a bit tricky. Although the idea that our universe could be inside a black hole is mathematically plausible, there is currently no way of testing it directly. The event horizon of a black hole is like a one-way boundary. Once something crosses it, it can never come back. This means we can't observe what's going on inside a black hole from the outside. On top of that, the conditions inside a black hole are so extreme that our current understanding of physics doesn't apply, so it's difficult to predict what's really going on inside. However, there are some intriguing indications that black holes might be linked to the larger structure of the universe. For instance, the expansion of the universe is accelerating, driven by a mysterious force called dark energy. Some scientists think that dark energy might be connected to black holes in some way, maybe as a result of the process that created our universe inside a black hole. Or some people think that the quick inflation that happened in the early universe, a period of extremely fast expansion right after the Big Bang, might also be connected to black hole physics. Even though there isn't any solid proof, the idea that black holes could create new universes is still a popular topic of study. One of the most well-known attempts to develop this idea further is Roger Penrose's theory of conformal cyclic cosmology, CCC. Penrose suggests that the universe goes through endless cycles of expansion and contraction, with each cycle ending in a massive black hole that gives birth to a new universe. While there is some mathematical support for this theory, it is still just a theory, and there is no definitive observational evidence to back it up. Ultimately, the notion that we're inhabiting a black hole, or that black holes could spawn new universes, remains one of the most fascinating and thought-provoking concepts in contemporary physics. It challenges our understanding of space, time, and the very nature of reality, but it also shows how much there is still to learn about the universe. As we keep on exploring the cosmos and learning more about black holes, we may one day find out if this bold theory is right. As we explore the cosmos and black holes further, we find ourselves asking some fascinating questions. For instance, if black holes can spawn new universes, what would these universes be like? Would they be like our own, or could they work under different laws of physics? If each universe is born from a black hole, it could have its own set of characteristics, which makes studying black holes important not just for understanding them, but also for uncovering the many possibilities of existence. What's more, if our universe is actually inside a black hole, it brings up some pretty deep philosophical questions about our existence. What does it mean for us to be part of a universe that is just one of many? What does this mean for our understanding of life, consciousness, and the nature of reality? It challenges the idea that humanity is the pinnacle of existence. It's possible that we're just tiny specks in an infinite tapestry of universes, each with its own evolution and destiny. The study of these ideas isn't just theoretical, New data from observational astronomy is helping us understand black holes and their role in the cosmos better. For example, the Event Horizon Telescope has captured images of black holes, and future observations could reveal more about their properties and behaviors. Instruments like gravitational wave detectors, such as LIGO and Virgo, are already helping us understand more about black hole mergers and giving us clues about the processes that govern these cosmic entities. On top of that, researchers are looking into how quantum mechanics relates to black holes. The famous information paradox, which was first raised by Hawking, asked whether information that falls into a black hole is lost forever or if it can be retrieved in some form. This paradox is connected to the idea of multiverses and could help us understand black holes better and their possible role as gateways to other universes. To sum up, the idea that we might be living inside a black hole or that black holes could create new universes is one of the most intriguing concepts in modern physics. It makes us think again about how we see the universe, challenges what we thought about how it all began, and suggests there might be an endless multiverse out there. While there's still a lot to discover and more research is needed, exploring these radical ideas shows how curious and innovative we are as humans and how we want to understand our place in the universe. As we keep pushing the boundaries of what we know, we might one day find out what's going on inside black holes and figure out what our universe is really made of. The study of black holes and what they mean for the universe is not just an academic pursuit. It could well revolutionize our understanding of reality. The idea that black holes could be gateways to new universes suggests that the fabric of the cosmos is far more complex and interconnected than we previously thought. It's possible that each black hole is a portal to a new universe. Each universe could be a unique expression of the cosmos, and we might be living in just a small fraction of what is possible in this vast multiverse. What's more, as we look to the future, the technology and methods we use to explore these concepts will evolve. The next generation of space telescopes and observational technology will help us understand more about black holes and how they affect galaxies and cosmic structures. These new developments could help us either confirm or disprove existing theories and improve our understanding of how the universe is put together. The discussion about black holes and how they might create new universes also shows how important it is to work across different areas of expertise. It's important that physicists, astronomers, and philosophers work together to bridge the gap between what we can see and what we can only guess at. This kind of collaboration could lead to some new and innovative ways of testing these theories and expanding our understanding of some of the fundamental questions about existence. As we learn more about black holes, we also have to think about the ethical implications. If we are part of a multiverse, how does that affect our responsibilities towards our own universe and the life it supports? When we realize that we may only be a small part of a much bigger universe, it makes us realize how important it is to look after our planet and the life forms that live on it. To sum up, the radical theories about black holes being the genesis of new universes raise a whole host of questions about existence, reality, and the interconnectedness of the cosmos. They challenge our understanding of physics and the fundamental principles that govern our universe, pushing the boundaries of scientific inquiry. While we may be on the verge of understanding these complex cosmic phenomena, the journey into the depths of black holes and their implications for the multiverse is still in its infancy. As we explore this new territory, we're hoping to solve some of the mysteries of our universe and understand our place within it.